We continue with last week's problem. Okay, now it is found that 95% of a candidate who sat for the entrance exam to enter a boarding school passed all the subjects. Okay, now there is a Bernoulli's trial here. The Bernoulli's trial is pass all the subjects or didn't pass all the subjects. Pass all the subjects is success, didn't pass all the subjects is failure. Okay, so we have two. So this is the Bernoulli's trial. Okay, so for all the binomial distribution questions, you have to first identify the Bernoulli's trial. In the Bernoulli's trial, there is the probability of success P. In this case, it is passing all the subjects, and the value of P is 0.59. Then the complement is Q, didn't pass all the subjects. So this Q is actually 1 minus P, and the probability in this case is 0.41. So this experiment here, take one student and see whether they pass all subjects or not. This is a Bernoulli's trial. This Bernoulli's trial is repeated several times. How many times is it repeated? 4 times. How do I know it is repeated 4 times? 4 pupils are randomly selected from the candidates. So in this case, n equals to 4 because it is repeated 4 times. The probability P is 0.59. 59% you change to probability is 0.59. So what are the things that you need to identify? Number one, Bernoulli's trial. What is the probability of success? What is the probability of failure? First thing you must identify. Second thing, this Bernoulli's trial is repeated how many times? So that is the second thing. So in this case, it is repeated 4 times. Then number 3, what is the discrete random variable? The discrete random variable is the number of pupil passing all the subjects. What can this number be? 0 to 4. 0, 1, 2, 3, 4. So this is the discrete random variable. The discrete random variable actually comes from how many times the experiment is repeated. So if 4 times, that means n equals to 4, x equals to 0 to 4. Okay, now so it is a matter of failure or success. Failure or success. If you refer to this table here, failure means didn't pass all the subject. Success means pass all the subject. So it is actually a sequence of failure and success. Failure and success. How many of them? All together, 4 of them, right? So that is the binomial distribution. Okay, so when you follow the tree diagram, you can list out all the possible outcome. So this possible outcome can be fail, 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 and success, failure, 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 success, failure. So there are many different permutations of success and failure. There are also different number of success and failure. Okay, right. So we are going to look at the next part. Now we want what is the probability of 2 pupils pass all the subjects. So we have altogether 4 pupils, the n equals to 4. So we want 2 of them pass all the subjects. That means the other 2 must be failure. They didn't pass all the subjects. So 2, 2. right? So how to count the probability? Now, before we count the probability of having two success, we want to know how many different possible outcomes. How many different possible outcomes with two success? So the different possible outcome, they are SSFF. That means success, success, the first two students success, the second two student, the next two student fail, failure. Okay, it's a failure. So it means that pass all the four subjects, pass all the four subjects, didn't pass, didn't pass. But it can be SFSF. The first one pass, second one didn't pass, third one pass, then the last one didn't pass. So there are many different ways of two students passing all the subjects. So the different ways I have listed out here: SSFF, SFSF, SFFS, FSSF, and so on. So when I count all these, they are all together 6 possible outcomes, which has 2 success. Of course, 2 success means 2 failure. So there are altogether 6 cases. Now, if I want to look at the tree diagram and choose the one with 2 success, or maybe the x equals to 2, quite difficult. It is quite difficult. So sometimes you count, you may count wrongly, all the 2 there, because there are so many with 2 success. So instead of counting from the tree diagram, there is a shortcut. The shortcut is we use our knowledge of permutation. So this SSFF is actually a permutation of 4 objects with 2 identical ones and another 2 identical ones. Okay, very unstable, the internet. Okay, 2 success and 2 fail, right? So 2 identical objects and the other 2 identical objects. So how to count? So to count the number of outcome first, we don't count the probability first, we count the number of outcome. Okay, okay, are you here with us? Yes, okay. So we count the number of outcomes. The number of outcome is just like arranging 4 objects with 2 identical ones and 2 identical ones. So it will be 4 factorial divided by 2 factorial for the 2s, 2 factorial for the 2f. But when I look at this 4 factorial over 2 factorial, 2 factorial, it looks like a number which is familiar with me. The number that is familiar is 4 choose 2. And sure enough, 4 choose 2 is also 6 ways. So without listing out all the possible outcome, I can count the number of possible outcome. Okay now? So now the number of possible outcome with 2 success counted already. So now I want to count the probability. Now if you want 2 success, it means that 0.59 times 0.59. So 2 success. Then if you want 2 failure, 2 success means 2 of them, the other 2 must be failure. So be 0.41 times 0.41. So in other words, it is 0.59 to the power of 2, 0.41 to the power of 2. Okay? But this probability has 6 possible outcomes. So I multiply by 6. This will give me the probability of x equals to 2. This will give me the probability of 2 success. This will give me the probability of 2 pupils passing all the subjects. So 2 people passing all the subject means 2 success. In any question, you can always count them as success and failure. No need to be 2 pupil pass or maybe 2 white cars, 2 green cars, or what. But it is every success, right? We just say success and failure. So this is the probability. Now, another way of writing the probability is like this. We want the probability of x equals to 2, which means 2 success. We use 4 choose 2, right? 6 is actually 4 choose 2 times 0.59 to the power of 2. This number 2 here is the same as the number of success here. 2 success means 2, and 0.59 is also to the power of 2. Then the other one, if you have 2 success means you have 2 failure, so 0.41 to the power of 2. Okay, now we go on to another case. The other case is this one. 3 pupils pass all the subjects. Okay, now before I go on, can you tell me how many outcomes are there with 3 pupils passing all the subjects? How many possible outcomes? Success, 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 then failure. Success, success, failure, success. Altogether, how many possible outcomes with 3 success and 1 failure? They say 3 success, automatically there is 1 failure there. So how many are there altogether? Can you tell me how many possible outcome with x equals to 3? 3 success. You can always refer to the table here to count. Oh, how many outcome has 3 x equals to 3? Okay, but what is the shortcut? Can you remember what is the shortcut for counting the number with x equals to 3, the number of outcome with x equals to 3? Anyone?
4C3.
Correct. 4 choose 3.
The
Okay, correct. Betul. Good. Okay, 4 choose 3 means out of the four trials, you want 3 of them to be successful. So out of 4, you choose 3. So 4 choose 3 means how many outcome? 4 outcome, 4 cases, right? What are the 4 cases? SSSF, SSFS, and so on. Now it comes to the probability. Now you say that there are supposed to be 3 success. So the probability of success must be to the power of 3. You say there is what 3 success, that means there's 1 failure. 1 failure, that means the probability of failure is to the power of 1. So let's see if it is correct. Yes. So there are 3 success means the success, the P, you have 3 times. Failure, you have 1 time. This is the probability of 3 success, or x equals to 3. But this type of x equal to 3 has 4 cases. So you have to multiply with 4, right? Now in any of these, in any of this probability counting, there must be 3 components. The 3 components, they are, the first one, how many outcome are like that one? Then, how many of them are success? If there are that number of success, then how many of them are failure? Okay, sometimes it may be all success and no failure. So the failure is 0, success is n. So when you count the probability, there are always 3 components. The 3 components are the number of outcome, number of success, number of failure, the 3 components. So it's very easy. This probability, find the probability of a binomial distribution, very easy. Only 3 components, right? Okay, so now we're going to look at the last x. X equals to 4. That means all the 4 students that we select, all of them pass the 4 subjects, right? All the 4 of them pass all the subjects. So for this one, x equals to 4, how many outcomes are there? Only one
1.
outcome. correct. Only one outcome. How to count this one outcome in our permutation or combination way? How to count this number of outcome? How to count? This one is 4 choose 3. This one is 4
4
choose
choose
2.
4.
4 choose 4, correct. So the number of outcome, the probability is 0.59, 0.59, 0.59, 0.59. So it's 0.59 to the power of 4. And it is 0.4 choose 4, 0.59 got 4 times, 0.41 0 times, 0 times. So you can see that there's always three component there. Number of outcome, number of success, number of failure. Always have three components there. Okay. So the three components we can actually, before I continue, any question on this binomial distribution? Binomial distribution is actually the distribution of probability. It's a distribution of probability like this. Zero success, what is the probability? One success, what is the probability? Two success, what's the probability? But then for each of these discrete random variable x, there are three components. Let's say take this one, x equal to 3, the component 4c3, success to the power of 3, failure to the power of 1. Let's say we take another component, x equals to 1. X equals to 1 has three components. Number of outcome, 4 choose 1. Probability of success, only one time. Probability of failure, 3 times.